Cubic graphs, sketch the graph. So, we go through the motions, we're thinking positive graph, right?
Yes, ma'am.
Or the shape. Second thing we're looking for is the y-intercept, which will always be there. You can't have not have a y-intercept. The y-intercept is -1. When we're looking for the x-intercept, we let y be equal to 0, the processes we go through, and it tells us that 0 is x to the 3 minus 1. Then we need to factorize, solve for x. And the method is factorizing. It's only linear equations that you get the x alone. Then you've got exponential equations. This is not an exponential equations. All the rest, being squared, being to the power 3, 4, 5, 6, which you don't do at school level, is going to be factorization. If I try to factorize this, our new method is James Bond, right? And go get your first, but it's not necessary. This is the difference of cubes. Remember that this is type number 6, Batman. It's type number 6 of the factorization. All the others can still appear. Common factor. Difference of squares, not in a cubic one. Are you with me? But look for all the factorizations if you have to factorize. This is the difference of cubes, which you do in which method, if we can still remember. The first bracket or the first factor is a 2-term, a linear one. Then it's going to be a 3-term, which is going to be a quadratic one, like you do in the Batman. But then this one will be the square roots of everyone. Square root of x to the third is just x. Square root of 1 is just 1. But the minus,
You take down.
you just take down. Then in the quadratic trinomial, you're going to have this recipe. It's the first one squared, so it's x squared. The last one squared plus 1 times plus 1 is plus 1. Or you with plus 1 times plus 1. -1 times -1, or just -1 squared is positive 1. For the middle term, you multiply the 2, gets you minus x. But it changes signs to become a plus x. That's the recipe you were taught with sum and difference of cubes in grade 10. So there comes out of the blue long ago's information that you had. But this then gives me my answers. Now what will happen to this one? Now it's a known fact that this will not be able to factorize again. And if you forget it, you could still go say, well, then x minus 1 is 0, so x is equal to 1. And if you want to go do that equal to 0, try to find factors. You're not going to find factors that gives you 1 in the middle. Then you maybe will go for the quadratic formula, and you'll find that it's non-real. You're going to get an answer that's non-real with a negative inside of the root. But that'll always happen. So this one has no solution. You don't have to write that. But knowing it is a good thing, that this one will give you an answer, but there will be no x-intercepts there. So in other words, now I'm thinking maybe the graph looks like this, and it only cuts through the x-axis once. Okay, next one, find your turning points. Now your turning points, there should be 2, right? Normally. So when we take this, we're going to do the derivative, which is the gradient, and put it equal to 0. Because in the point where it turns, the gradient is 0. So we do the derivative. Do the derivative, you only get 3x squared. Which when you solve it with more or less steps, it's going to give you x is 0. There's no other way that that 3x squared is equal to 0 unless x is 0. You could have said divide by 3, then square root it, but square root of 0 is still going to be 0. Plus minus 0, because it's a square root, it's still 0. X is equal to 0. So I only have 1 turning point. But that means if I only have 1 turning point, it will be a point of inflection. Now, if you go and check it, you're going to find for x, if x is 0, the point is going to be 0 goes back into the x there. And the answer is -1, which was my y-intercept. So I've got a whole lot of just a little bit of things. So on my sketch, trying to sketch, I've got the y equal to -1. I've got my x value is equal to positive 1, and make your graph a little larger rather than smaller so you can see what's happening there. But then I've just found out that my turning point is not really a turning point, it's a point of inflection. So thereby the negative 1, the y-intercept is my point of inflection. So the point of inflection, what happens there? What happens to the graph? It's a yes, the concavity changes. There's a change in concavity. So how would I have this happen then? It's got to go through there. So it's got to go upwards. Please not like that. Because then it doesn't make sense to the concavity. It has to go upwards. It has to go downwards. Because you knew. Not exactly what's going to happen, but it has to first increase. Then increase. But because it doesn't have a turning point, it's going to increase and inflect and still in fact be increasing. You see this graph is going to continue being increasing through the point of inflection. Full marks. Happy on that? Okay, if we wanted to check the concavity, since that is our latest thing, what would be the concavity in the point where x is equal to negative 2. So, say I did not sketch this. I've got to do a soon sum. If I ask it here, you're going to say, well, x negative 2 is here, so the concavity there is down. And you've got full marks. But let's say you didn't have the sum, you only had fx equal to x to the 3 minus 1. You had to go and find the concavity. Concavity is everything to do with double derivative, your second derivative. So you've got to go do your first one, we're making as if we haven't done it yet, which gives you 3x squared, right? Then we'll do the double derivative, which is going to be 6x, and we're going to put it equal to 0. Do I put that equal to 0? Why would I put it equal to 0? I'm not looking for the Why would I not put it equal to 0? I'm not looking for the gradient, where the turning point is. If you ever put the derivative equal to 0, you're looking for the turning point. Is the derivative always equal to 0 anywhere? No, because it's gradient. It will change from point to point, but only be equal to 0 in the turning point. If you put the double derivative equal to 0, what are you looking for?
The concavity.
The point of inflection. So should I write equal to 0? Am I looking for the point of inflection? I'm not. And if you write 0 when you shouldn't, or you don't write it where you should, you're going to lose marks. I'm only looking for the concavity in that point. So I'm looking for the derivative. But then, in the point where x is, that means my double derivative, I'm going to take the x and substitute it, function notation, with a negative 2. So I'm only looking for the concavity in some random point. And this answer is, the fact that it's 12, negative 12, doesn't make the difference. It's because it's negative. If the double derivative is negative, it's concave, downwards, down, whatever you'd like to say there. Are you with me? You'll remember it. But no, it was stupid if I asked it after sketching it. Then everybody will just see, oh well, if it says downwards. Anywhere there, it's upwards. Remember, it's like completing a parabola almost. It's on its way to be downwards, it just never gets there. This one is on its way to be upwards, it just never gets there because of the point of inflection. So whenever you need to test concavity, you do it with your double derivative. Please be careful not to put the double derivative just randomly equal to 0, because if you do that, you're looking for the point of inflection, and that would have been the sum. Finding the turning point. Now, a lot of people, even me, likes not to write turning points. They rather want to write stationary points. Now, stationary points are when you go on your graph, when you get to speed with the derivative, the gradient is going to give you speed. So if you're thinking speed here, the speed is going to decrease, right? To get to 0. And then increase again, and then decrease again, and then increase again. But in the point, the turning point, it's going to stand still. So if the gradient is 0, then the speed, which is your gradient, which will be your derivative, will be equal to 0. So they talk about stationary. Now, if they say there's a stationary vehicle on the R29, what does that mean? It's standing still, it's not moving. So what is a stationary point? And that would be my abbreviation for it. So a lot of people like to just write stationary point, because in actual fact, we found that the turning point is not a turning point, it is a inflection point. Both of them are stationary points. Guys, this is way too technical. Don't get lost on it or hooked on it. If you don't write stationary point, it's fine. As long as you realize if there's only one x-intercept, it's got to be only one turning point. It's not a turning point, it's got to be a point of inflection. Good. Okay, guys, back to grade 11 and 10. When you were taught new graphs, new functions, you were always taken back and said, you have to be able to sketch them, which we've done now with the cubic graph, and then you've also got to be able to find their equations. Now, straight line equation, you've either got 2 points, you've got the y-intercept, you've got something, and you can find the equation. Parabolas, writing June exam on this. In a parabola, how do I find the equation? What are the rules? 2 ways of doing it. I either give you the x-intercepts and a point, then the formula is y equal to x, a, bracket, x minus x1, x minus x2, fantastic, I see you with me. If it's a turning point and a point, the formula you use is y equal to a, x minus p squared plus q, because that's the turning point, fantastic. If it's a hyperbola, you've got to be able to see your asymptotes, have more points on it. Exponential, I'm being very vague here now. Same thing happens with this cubic graph. So if I ask you to find the equation, what would you do? So there's only one formula to know, but there are different techniques that you're going to see popping up when you're doing some exercises. The first formula that you can get will remind you of something. What does that remind you of? Parabolas? X-intercepts. Something like a year. Because you have 3. That's it. That's the formula to find the equation of a cubic graph. If I have the 3. Now, please remember, you were taught, sometimes there's one that bounces. If it's bouncing, then you'll only have 2 of them, and you'll just put a square by whichever the one is that is bouncing. Are you with me? Yes. All the stuff that you learn in forward, you must work in backwards as well. So this one was clearly 3 x-intercepts. What do you think we're doing? Substituting the x-intercepts just like with your parabolas, with what? Plus 5, excellent. Remember the formula? If it says negative for a reason, you've got to always change those signs, like with the parabola, alright? And then it'll be plus 1, and then it'll be minus 3. Just now, somewhere in the paper, they give you this formula, and they make it plus, plus, plus. Are they wrong? No. You've got to use it, changing the signs. You cannot tell them that they are wrong. We just use it correctly. This must always change. So let's go back to grade 10 and 11. The teacher asks you now, what do you see? How many unknowns do I still have? 1. Which is? How do I find one variable? You're so clever. See, if you know the background, you can start doing new stuff with your background. Substitute what?
4 and 4.
I'm going to give you something else. So that point 4 and 2. Why can I not substitute one of these in? I've already used them. If you do that, you've been taught this as well. In any graph, If you substitute a point that you shouldn't have substituted because it's already been used, but you forget, what's going to happen? The A that you're looking for is going to go poof. Then you know, choose another point. Okay? If it's gone, the A that you're looking for is gone, you've chosen the wrong point. Okay, so let's do it. So the Y is going to be 2, the X is going to be 4 in every space. And you take your calculator. Because you've got to first add and add and add, multiply them all together. 45, I agree. So all of that times is 45A, because we always write the A at the back. So that we're finding A is equal to, which is horrible, but so be it. If A is positive, what makes my heart go a little bit yes?
The graph is the right.
Because of the shape, right? A can't be negative, because then it would have looked like that. It has to be positive, so it's a little bit of a confirmation for me. Am I done? Definitely not. They want me to find the equation in this form. Just like in parabolas, were you ever allowed to leave your answer like this?
If they don't.
Never. Even if they didn't say anything, you were never allowed to use that. If in a parabola your answer was that, could you leave it like that?
Yes.
Yes. Acceptable. Turning point 4. Yes, you're allowed. But never in x-intercept form. Whether they say it or not, you have to time it out. Same thing here. So we would leave it. Just say now the question paper says. Find it in the form. Bracket, bracket, bracket. Then you're allowed to do it, and please do it because this is going to take us 2 minutes to do. What must we do? Distribute. Oh. Are you with me? Ha. But let's do it. And it doesn't matter where you start. Sometimes there might be a difference of squares or something like that that can help you. Please look for it. But there's nothing helping me here. I've got to do 2 of them. I'm going to do these 2. That's my choice. Okay, when I do those 2, then I still have to distribute this in. And you can do it all at once, but rather be careful. So we're going to do the x, so it's going to be x3 minus 2x squared minus 3x. Then we're doing the 5 plus 5x squared minus 10x minus 15. And then the last step is to time all of that in. Well, I've still got to simplify, right? x3 plus 3x squared minus 13x minus 15. Check up on me. If I go so fast, I might make a mistake. And then the answer is 2 over 45 x3. 2 over 45 times 3 will give me 2 over 15 if I'm right. And this one will be 26 over 45. And this one will be 2 over 3. If I'm right. Just double check me on my calculations there. So you're timing out with your calculator. Thank you. If the sum had said, find A, B, C, D. I'm not done. Answer their questions. A is, B is, C is, D is, because that would be worth another mark because they asked for it. So please answer the questions. So we have done finding the equation. So like I said, if you've got a graph that looks like this, going through -1 and 2, how would you apply that on your formula? So this would have been +1. But then you would have 2 of them being -2 and -2, or you can put the bracket to the power 2. Are you happy on that? Okay, so you know, when the formula comes now, and I tell you, go sketch me this thing. Please go and sketch me some other thing. Let's make it up. It won't work now because we're just making it up. What am I giving you?
The x-intercept.
The x-intercepts, now that you know it. I'm saying, hello, there's the x-intercepts. Please don't go do Batman on your own. I've given it to you. So the x-intercepts are 2 and 3 and negative 5, and you have to time it all out to get the turning points because you can't derive if it's not timed out. Are you with me?
Yes, ma'am.
And the shape is going to be,
Positive.
because whether I time it out or not, the A is still the A and it's positive. Alright, happy on that?
Yes, ma'am.
Okay, let's do a little piece extra. To find the equation of a tangent to the graph, and now I wrote it in the beginning and I thought I must really discuss this with you. It's easier for me to say now a tangent to, now I don't have a name for this thing. So most often they write fx. So I can say here tangent to
FX.
f, because f is fine, to f in the point where x, well let's make that 4 and 2. So in other words, at any point I can get a tangent to this graph. So that would mean over there, that my instinct is telling me this should be a positive gradient. Because now remember, a tangent is a line, first of all. It's going to be mx plus c. And that mx plus c, or whichever formula you'd like to use, that m is going to be found by doing what? Differentiation, because that's the gradient. And then again, to do differentiation, I need this f to be able to say the gradient is where I take f and I derive it. But do I put it equal to 0? I'm not going to find 0 now. This is the gradient in that point, it's not going to be 0. So when I put it in, I've got to put in the value of x. I want the gradient in the point where x is. So that's why my gradient is going to be going to where? What must I do? First find your derivative, which was a horrible thing, because ma'am has now just sucked this out of her thumb. So it's a horrible sum. Horrible sum, nice sum, I don't care. Okay, let's help me here. So that's going to be some toughie. So 15 x squared. Happy? And then the next one?
4 over 15.
Okay, and the next one? So whether it's nice or not so nice, the principle stays the same. Exponent times coefficient. Why did I do this? Because I want to get to the gradient. The gradient of this line somewhere. And there can be infinitely many tangents because in every single point there's a gradient. I want the tangent in that point. So if I go to that one, I've got to say for the gradient in the point where x is equal to 4. Because that's the point I want the tangent to. I take 2 over 15 and I take x in all of the spaces and substitute with 4. Because you're working the gradient in the point where x is 4. So the gradient depends. This is gradient. The gradient depends on where your x is. From point to point to point, the different x's are going to give you different gradients. Only with a straight line is the gradient constant. It will change from point to point. So we are substituting with 4. And the answer, please? Somebody confirm? It's positive. That's the first thing I'm checking. How come? Look where it is. Now that you won't always have. If you have a sketch, then you can estimate. If it was a point somewhere here, the gradient would have been negative. Anywhere here, next to that turning point. And I don't even have the turning point. Are you with me, guys? So I can estimate. I think I'm kind of like on the right track. But now to find the whole equation, what do I need?
X intercept. The y intercept.
Okay, so for the tangent so far, I've got y equal to 118 over 45 what a gradient plus, so what am I looking for? C. How do you find one variable?
Substitute.
Which point?
4 and 2.
Only that point. No other point is on that tangent. The only point where that tangent touches the graph is in that point. Are you with me? So we substitute 4 and 2. So this is like a recipe sum. You're always going to get the gradient going back to the original graph, because the original graph's derivative will give you gradient from point to point. And then we've got 2 equal to, and times with 4. So we are really, a man chose a horrible one, working out 2 horrible answers for you. But I'm guessing it's going to be a minus answer. Look at this. Because if it's going here, C is the y-intercept. So it should be negative something, something here.
Negative 182 over 45.
Oh, am I done?
No.
Please complete your question. So the equation is y is equal to 118 over 45x minus 382 over 45. Please don't be cute there and do all sorts of things like mixed numbers or decimals. Just leave it like that. Horrible, they don't in general look at some that workouts are horrible, but that's not to say they can't be fractions. And even if it is, somebody sat there and said, like I just did, nothing wrong with the sum, just makes me feel uneasy with these strange fractions. Okay, so today you learned how to find the equation using your new formula with 3 x-intercepts. You also learned how to find a tangent equation. Please remember that a tangent is always still y is equal to mx plus c. And what does the tangent have to do with the graph? The m is the connection. The m is where you derive, and in any place, I want to stress this, that m is the gradient at any point, depending on which x you at. If you have a specific x at its place and you know it's by x equal to 300, you'll be able to find the gradient in that point because you have the x. The gradient is dependent on the x value. Now sums are going to come, and I'm only going to say, listen, find me the gradient in the point where x is 4. I'm a little bit stuck then here, am I not? But how will I then find that to? If I only gave you x is 4 on the graph, how can I find its partner y?
Substitute into the original formula.
Exactly, that's it. They normally, if they do that, then it doesn't work out to such large numbers, but they can do that then. Because now the horrible thing is all of these fractions, and you've got to go now and substitute for 4 everywhere. What you're going to get? 2. And then find out that it's 4 and 2, because you need that to substitute in your point. You can't just have 4, because then I'm not going to finish my sum. So what did you learn from there? If I have the x, I can always find the y, or the y, I can always find the x, but I need a full point to be able to find the full equation. Good. Just your homework is number 10 and 14. It's 10 and 4 on page 225.